Hello everyone. Now let's work on the virtual lab 2. So here you see we can work on the first task. Use the virtual laboratory to standardize the unknown sodium hydroxide solution, approximately 0.2 molar. Okay, that's the rough concentration, to 4 significant figures via titration with a 25 0.0 milliliter of a potassium HP standard solution. What must be the minimum concentration of this solution to yield the required accuracy in the sodium hydroxide results? Well, so you can read this, and this information are very important. And then here in the following, I will show you how to do the experiment, do the virtual lab. Okay, so first we go to we go to find this offline software, and then we click application. Okay, and then now we're entering. Wait, let me see. Can we make it bigger? Oh, it seems that we cannot make it bigger. Okay, we can just use that. So we first need to load, and it is acid and base, and then it is pre-lab exercises here. Now problem 1 solution. Okay, here's the solution, and then as we discussed, we need to we know the concentration of potassium salt, potassium HP solution. We know the concentration, and we are going to use the following reaction. This KHP. I mean, is a abbreviated name. KHP represents this compound. Okay, KHP. Let's see. Yeah, here's the KHP. Okay, KHP. This is the KHP. Okay, KHP react with sodium hydroxide in 1:1 ratio. This is a acid because it has 1 proton here. This proton can be given away, and it reacts with sodium hydroxide in 1:1 ratio. Okay, in 1:1 ratio to afford the salt and water. You see, and then when the reaction reach the equivalence point, the moles of sodium hydroxide and the moles of KHP are the same. Okay, that's the principle for this titration. And then we know that let's see the problem 1 solution. Okay, so there are a few kinds, 0.1 0.000 molar KHP or 0.08 molar KHP. So you see the concentration of sodium hydroxide is around 0.8, and then theoretically we can choose all of them, but here for simplicity we can choose 0.1000 molar KHP because the volume of the sodium hydroxide will roughly half. I mean, will be roughly half of KHP solution, right? Because when the reaction reach the equivalence point, the moles of sodium hydroxide and the moles of KHP are the same, and then we can choose any of them. Here I just choose 0.1. Okay, double click, and I have this solution. See, and then on the right top you can see it's around 250 milliliter around, but the volume is very accurate. You see 0.10000. There are 4 zeros behind, and all these zeros are significant numbers. It means something. It means the accuracy. So 0.10000 molar has a specific meaning. It's not the same as 0.1 molar. Here, it means this one is accurate. and this 0 is accurate, this 0 is accurate, this 0 is accurate, and this 0 is uncertain. There is some uncertainty. If we only put 0.1 molar, that means the number 1 is not certain. There's some uncertainty there. Okay, the rough volume is 250 meter, right? And then we want to get a solution ready. Okay, so the first thing we need to find as you can see from the from this procedure, right? We want to titrate. We want to do the titration with 25 milliliter of solution. So here, this Erlenmeyer flask has 250 milliliter solution, and then we need to do some transfer. And normally for titration, we use Erlenmeyer flask. Okay, this is empty one. Empty one. Then we need to be aware we cannot just pour that. We cannot just pour. We cannot do that. The reason is because we cannot make sure the volume is exactly 25.00 milliliter. So if we just pour this way, we may not even be able to control the volume to be 25 milliliter, let alone 25.00 milliliter. So it's very accurate, and then we cannot do that. What we can do is to choose pipette. For this pipette, 25 milliliter pipette. 25 milliliter pipette can measure the volume very accurately. So, and then when we use 25 milliliter pipette to withdraw a solution, the volume of the solution is 25.00 milliliter. It's very accurate. So you see, we can transfer, we can do some withdrawal, and then again we go down to the bottom of this page and we put 25.00, and then you can see there are two options. One is withdraw, the other is pour. Here we want to withdraw a solution, right? Then we click withdraw. You see here at the bottom there's two functions. One is withdraw, the other is pour. In this case, we want withdraw. Okay, we withdraw 25. Okay, now we can transfer this 25 milliliter solution, right? 25 milliliter solution. And then in this case, we do again with 25.00 and we pour. Okay, this is very accurate. This volume is very accurate. We get 25 milliliter solution. So, and then at the top right, you may see the volume around 30 milliliter. So don't worry. The volume here is 25 milliliter. We don't need to worry about this. It says, you see the volume on the top right, it says around 30 milliliter. So we don't need to worry about that. We need to keep in mind the solution here, the volume is 25.00 milliliter, okay? And then when we do titration, what else we need? We need the indicator, right? We need the indicator. Here, this is the indicator. Here's the indicator solution. Phenolphthalein, okay, phenolphthalein anyway. So it's the indicator. Okay, this is indicator. So indicator solution. Now we want to add some. We want to add some to add a few drops actually. Add a few drops to this Erlenmeyer flask because this one can serve as indicator. What we're going to do? We can we need to use pipette. We use pipette. We use a disposable pipette, right? Disposable pipette, and then you can see whether you can take some drop. You see there's a red sign there. There's a red circle sign. It means this cannot be done. Okay, this cannot be done. And then the reason is because normally we cannot do that. Normally we need to first pour the solution into a beaker. You may think about why, and then the reason is because if this pipette is contaminated, then the whole stock solution is contaminated, and we don't want that. And in this case, we can just pour. You see, it's green. We can pour how much? We can pour maybe 10 milliliter. Let's see, 10 milliliter. We put 10. We cannot put 10.00 something, right? It's not accurate. We cannot pour that accurate because when we pour, we use our hand, and then we pour 10 milliliter. Okay, we pour. Okay, 10 milliliter, and then we can withdraw some. You see, now this is green. It's green light, right? Means this can be done. And how much we need? Normally for indicator, we only need 2 drops. 2 drops is very little. So here we can just put 0.01 milliliter. So 0.01. We can put 0.01 milliliter because we don't need much amount of the indicator. And then withdraw. Okay. And then we can pour this here. Okay. And then we same amount. Just now we withdraw 0.01 milliliter, and now we pour 0.01 milliliter, and then we pour. Okay. And then we can click this solution. You see on the right column, we can see there is KHP, right? There's KHP, and then because just now we transferred 25 milliliter of solution, and we also add some indicator. You see, that means we successfully added some indicator to this Erlenmeyer flask. Okay. Okay, just now we add 25.00 milliliter KHP solution, and then we also add some indicator, right? And then so this is confirmed as we click the container. You see, as we click, we can see the information. It has KHP, it has indicator, and then we can rename it. We can name it 25.00 milliliter because the concentration is 0.10000 KHP plus indicator. We put indicator, right? We have all the information, and then we click. Yeah, okay. So this now we need to fill the burette with sodium hydroxide, right? Before we do titration. And here's 0.2 molar sodium hydroxide. Okay, 0.2. So this is a solution. And then we need to fill we need to find a burette. So let's see, this 50 milliliter burette, right? This 50 milliliter burette. And then we can first transfer this solution to here. Okay, you see it shows green light. Then we can do that, but we need to be very careful because remember, when we transfer solution this way, we use our hand, and our hand cannot control very well. So, as you can see from the procedure, if we choose, for example, if we choose to add 50 milliliter solution here, then it's very likely we may add 52 milliliter solution. Then that will cause overflow. So we cannot do that. Before we determine how much we want to transfer, we need to do some simple calculation. Okay. Remember here, let's put this solution together. Right, is this solution together? So this solution KHP is 25 milliliter, and the concentration is 0.1, right? And the concentration of sodium hydroxide is 0.2. And then if we look at this reaction, they react with each other in 1:1 ratio, same moles. Okay, same moles. They need to be around same moles. Okay, and then we go back. No, sorry, here. Then we go back. Here, KHP solution is 0.1, 0.000 molar, and it's 25 milliliter. Then sodium hydroxide 0.2 is concentration is about twice of the concentration of KHP. That means we need half of the volume of KHP for sodium hydroxide, right? Around 12.5. So basically we need to add 12.5, around 12.5. We don't know exact amount we need. So that's the reason we do the titration. And then you see here we can just add, for example, we can just add 40 milliliter solution. We can just add 40, around 40, because if we add 50, it may overflow. If we add 40, then it's very unlikely that we overflow the burette. Okay, we add 40. So 40 is more than what? It's more than 12.5 that is needed to complete the reaction, right? So we add 40. And we may use it, we just put 40. We don't put 40.00 because for this kind of transfer, we cannot reach that accuracy. We put 40. We don't put 40.00, okay? We put 40 because that is the accuracy our hand can reach when we do this kind of transfer. Okay, we pour. Oh, there's one thing I need to tell you. There's one thing. Let me go back. So we remove this one, and we also remove this one, and then we put sodium hydroxide again, and then we put a burette. Okay. So we do the titration. There's one thing. Okay, you see, before I do the titration, you see the reading, the scale, the reading here is 40, 50, 40, 30. So for a 50 milliliter burette, the 50 scale, the bar, the reading is over here, is not top. It's not top. So we need to keep this in mind. So the 50 for 50 meter burette, the reading is here, is at the bottom, is not at top. And when we transfer 40, okay, and when we transfer 40 milliliter solution, you see the solution reached that level. Okay, you see that? You can and then the difference, and then let me see, I need to get a calculator. Okay, and the difference of the reading, it is the volume we add. So at the beginning the reading is what? Is 50, right? Remember, 50. And then now the reading is how much? Is 6.90. Okay, we can put a 6.90. So yeah, we add 43.1 milliliter. Okay, so 40, yeah, because we cannot control that very well. So when we plan to pour 40 and we end up adding 43.1, that's okay. And we just keep this in mind. But we do need to record the value here, 6.9. That's 6.9. That's the initial reading we need to record. We need to record. As we do the titration, the liquid level will keep going down. Right? And then the difference is the volume that we add to do the titration. Okay, so that's really we need to write down the initial volume is reading is 6.9. It's here, I think. Yeah, it's 6.9. Okay, and then we can start to do the titration. Okay, we can do the titration. Okay, how much we should add? You see here. Again, just now we calculated the rough amount for sodium hydroxide to finish the titration is 12.5 milliliter. So it's kind of safe that we can add 12 milliliter solution first, right? Or maybe 12.1. Let's see, 12.1. Here we need to add very accurate because burette is very accurate instrument. So we can control the amount very well. So we first add 12.10 milliliter, then we pour. So you see the volume increase, but you did not see any color change. We expect to see some color change, right? We expect to see some color change, and then 12 point, and then we already add 12.1. Then we can add more. We can add little by little. We can add 0.02 milliliter because we don't want to overshoot. Okay, we add. As we add, we need to pay attention to the color of the solution. No change. No change. No change. Then we keep adding. You see here, at the right bottom, there's a function we can choose. We can pour, and here's the volume on the here. We choose the volume we add. So as we approaching the equivalence point, we need to be very careful. We need to add slowly. Okay, we add. There's no color change. Add 0.02 again. Keep adding. Keep adding. Pay attention to the color, whether there's any color change. Okay. No color change. No color change. No color change. I keep adding. No color change. No color change. No color change. I just keep adding. As you see, as you keep adding, this liquid level keep going down. You see, I click once and you can see the volume going down. So I click once, going down. You see that? At the same time, we need to pay attention to the color change. You pour again. 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 You see, there's some color change, right? You see, there's some color change. And we can record the ending volume is 19.40, right? 9.40, 19.4. You see that? 19.4. Then we can tell the difference. The starting is 6.9. The ending is 19.4. Okay, and then 19.4 minus 6.9. Oh, exactly 12.5 milliliter. Exact 12.5. Yeah, if you're not sure, then we can add another 0.02. Okay, you see, I feel there's some color change already, but if you're not sure, this very slight color change, that's good enough. If you're not sure, then we can add 0.0, maybe 1. Let me see. We can add 0.01. You see, the color changed more. Okay, the color changed more. So, or you can choose this one. You can choose this as the equivalence point if you're not comfortable with the slight color change. And sometimes we can overshoot. That's okay. So we add 0.01. So that is the volume we use to finish the titration, right? And now we can calculate the concentration of this sodium hydroxide, right? So for the KHP solution is 25 milliliter times the concentration of KDP 0.1. So I don't put 0, 0, 0, 0. Okay, I can put it here. Then we get that. And then we divide it by what? 12.51 milliliter, right? So liter we can convert the milliliter to liter, but here we don't need to convert because these 2 milliliter units will be cancelled each other. And then we end up the unit as molar. So here you see that is the exact concentration. That is the exact concentration. So we need to in the real experiment when we add solution as we approach the equivalence point, when sodium hydroxide is dropped into the solution, then there's a then locally some solution will change its color, and then that tells how close the titration reaches the equivalence point. But here we cannot see that. So that's the reason I added 0.02 milliliter to in a very careful way. So we don't want to overshoot. Then here's the concentration of sodium hydroxide we figured out is, and according to the procedure, we need to find out the solution, the concentration of sodium hydroxide down to 4 significant figures. Then we should write the concentration 0.1998. So that's the concentration of sodium hydroxide. And then we can see here, describe what glassware you have to use to obtain the required accuracy. So we need to know what glassware we need to use to transfer the KHP solution, and what software we need to use to transfer the indicator solution, and what software we need to transfer the solution into the transfer the sodium hydroxide into the burette. So tabulate your titration data. You see, just now we record the initial volume is 6.9, right? And then the final volume is 12.51 or 12.50. And you can calculate the error is very tiny. So we don't need to worry about that. Okay, so we finished the first part of this experiment.